Overview of high-speed railway development worldwide. Transportation involves the movement of people and goods through various networks, and it's essential for both economic activities and daily life. Throughout history, the development of transportation has focused on improving speed, as it greatly impacts the effectiveness of a mode of transport. Speed doesn't just reflect technological progress, but it also drives economic and social development. Railway transportation, which operates on fixed tracks, stands out because of its large capacity, high speed, safety, energy efficiency, and environmental friendliness. The speed of rail transport is a key measure of its progress, and high-speed rail represents the modern evolution of railways. It's a major achievement in transportation, reflecting a country's technological, industrial, and organizational development. High-speed rail is particularly beneficial in economically developed and densely populated areas, leading many nations to focus on building faster, greener, safer, and more convenient railways. History of railway development. Early period, 1825 to 1900. Railways entered a new era in 1825 when the first steam-powered train, designed by Stephenson, traveled from Stockton to Darlington in the UK, marking the beginning of modern rail transportation. With its speed and reliability, railways quickly surpassed ships and carriages, becoming a dominant mode of transportation in the late 19th and early 20th centuries. This rapid growth fueled economic prosperity around the world. Growth period, 1900 to 1945. During this time, railways expanded rapidly, driven by the colonization efforts and industrial needs of European and American nations. In the U.S., for instance, railway mileage reached a peak of over 400,000 kilometers in 1916. By 1941, the global railway network spanned 1.26 million kilometers, with nearly half of it in the Americas and a third in Europe. Decline period, 1946 to 1964. After World War II, cars and airplanes quickly developed, and railways lost their appeal. As governments focused on road and air transport, railway services deteriorated, and regulations were introduced to limit railway operators' profits. By the mid-20th century, the railway industry saw significant declines in both infrastructure and passenger volume. Revival period, 1964–present. From the 1950s onwards, as highways and air transport grew, railways faced even more competition. However, as issues like energy crises, pollution, and traffic accidents became more pressing in the 1970s, people began to realize the value of railways. With its ability to carry large volumes of passengers and freight, rail once again became a vital mode of transport. The introduction of Japan's Tokaido Shinkansen marked a turning point, leading to the revitalization of railways, especially in high-speed transportation. The history of high-speed railway development. For over a century, railways dominated land transportation. However, in the 20th century, they faced competition from cars, airplanes, and pipelines. To stay relevant, many countries, including Germany, France, and Japan, began researching how to make trains faster. In 1903, Germany set a speed record of 210 km per hour with an electric train. France followed in 1955, achieving 331 km per hour. However, it wasn't until the 1960s that high-speed rail became a practical reality. The first wave, 1960s to 1980s, Japan and France lead the way. In the 1960s, Japan needed a modern transport solution for the 1964 Tokyo Olympics. They built the world's first high-speed railway, the Tokaido Shinkansen, which connected Tokyo to Osaka, covering 515 kilometers at a speed of 210 kilometers per hour. This innovation halved the travel time between these cities and marked the beginning of the high-speed rail era. The success of Japan's Shinkansen inspired other countries, especially in Europe. France soon developed its high-speed rail network with the TGV, marking a global railway revival. By the end of the first wave, high-speed railway tracks totaled 3,198 kilometers, covering Japan, France, Italy, and Germany. The second wave, 1980s to 1990s, Europe expands. Both Japan's Shinkansen and France's TGV were great successes. The Shinkansen became Japan's primary source of passenger transport income, and France quickly recovered its TGV investments within 10 years. Inspired by this, many countries reconsidered the benefits of railways, especially during the 1980s energy crisis and rising environmental concerns. Technological advances, alongside reforms in railway management, led to a second wave of high-speed rail expansion. Europe saw large-scale construction of new railways across France, Germany, Italy, Spain, and beyond, forming a growing high-speed rail network. The third wave, 1990s present, global expansion. The third wave of high-speed rail development spread globally. Countries across Asia, Europe, and even North America began building or upgrading their railway systems. China, Russia, South Korea, Australia, and others joined the high-speed rail race. Central and Eastern European countries also worked on improving their existing networks. By the late 1990s, high-speed rail was recognized as a key global transportation solution. Countries like China took the lead, building an extensive high-speed rail network, currently operating over 35,000 kilometers of tracks. China's progress is now seen as a benchmark in the world of high-speed rail construction. Future prospects. Even though high-speed rail has been developing for over 50 years, the demand continues to grow. According to the International Union of Railways, UIC, global high-speed rail mileage is expected to reach 50,800 kilometers in the coming years. Asia and Europe will remain the largest markets, with China, Russia, and India playing leading roles. Countries like South Africa and others in North America and Africa are also planning to expand their networks. Emerging economies like China, Russia, India, and South Africa will be key players in shaping the future of high-speed rail, which is expected to transform global transportation for decades to come. The concept of high-speed railway. High-speed railways are a modern and international development. The speed of these trains is not only a key technical factor but also a reflection of how advanced a country's railway system is. Classification of railways. The International Union of Railways, UIC, categorizes railways based on their speeds. Normal speed railway, 100–120 km per hour. Medium speed railway, 120–160 km per hour. Quasi-high-speed railway, 160–200 km per hour. High-speed railway, 200–400 km per hour. Ultra-high-speed railway, above 400 km per hour. Defining high-speed railways. Different regions define high-speed railways based on the speed of the trains and the development of their systems. Let's look at the definitions from a few key regions. European Union. In 1996, the EU established a standard for high-speed railways. Newly built lines should reach speeds of at least 250 km per hour. Upgraded lines should allow speeds of 200 km per hour or more. International Union of Railways, UIC. The UIC set similar guidelines. Newly built high-speed railways should have a design speed of 250 km per hour or above. Upgraded lines should allow speeds between 200 and 220 km per hour. Japan. As the pioneer in high-speed rail, Japan's high-speed system is known as the Shinkansen. In 1964, Japan set its standards for high-speed rail, defining it as a railway line where trains run at speeds above 200 km per hour on tracks with a gauge of 1,435 mm. This was the first formal national definition of high-speed rail. United States. The Federal Railroad Administration, FRA, in the U.S. defines high-speed rail as any railway operating at over 145 km per hour, 90 miles per hour. However, most Americans consider high-speed rail to be trains running at speeds over 160 km per hour. The only existing service close to this is the Acela Express, which can reach speeds of 240 km per hour. China. In China, high-speed rail refers to dedicated lines for passenger trains with a design speed of over 250 km per hour, and initial operational speeds above 200 km per hour. China's definition covers different types of high-speed trains, such as EMU trains and intercity trains. Quote, for China's high-speed rail system, on reconstructed lines, trains running between 200 to 250 km per hour are considered EMU trains. On newly built lines, trains running between 300 to 350 km per hour are classified as high-speed EMU trains. General definition of high-speed railway. Generally, railways with a daily or commercial operating speed of 200 km per hour or more are considered high-speed. Newly built high-speed lines must exceed 250 km per hour, while upgraded lines must reach at least 200 km per hour. As technology evolves and conditions change, the definition of high-speed railways will continue to be updated. Overview of high-speed railway developments in the world. High-speed rail in Japan. In April 1959, construction began on Japan's Tokaido Shinkansen line, connecting Tokyo and Osaka. After 5 years of work, the world's first high-speed railway opened on October 1, 1964. This electrified, double-track line was built exclusively for passenger transport and set the standard for high-speed rail technology. It marked a turning point, moving high-speed rail from experimental phases into commercial use. Tokaido Shinkansen brought a significant improvement in speed over traditional trains. After its launch, it attracted many passengers away from air travel due to its lower cost, accounting for only a fifth of air transport prices. This caused airlines to cut down on Tokyo-Osaka flights. Just 7 years later, the project had paid off its $1 billion construction cost with interest, achieving a remarkable internal return rate of over 12%. The Shinkansen is often considered the most successful high-speed railway in the world, contributing significantly to Japan's economic growth and inspiring a global trend in high-speed rail construction. It's even referred to as the backbone of Japan's economic rise. Quote, because of the Tokaido Shinkansen's success, Japan's parliament passed a law in 1971 to expand the network. Over the past 50 years, the Shinkansen system has consistently been a model of technological progress, safety, and reliability, with no fatal accidents. While its speed was soon surpassed by France's TGV, the Shinkansen remains a leader in high-speed rail operation. Japan's main focus in developing the Shinkansen was to increase passenger capacity, with speed being a secondary goal. Today, Japan's Shinkansen network stretches over 3,041 kilometers, with another 402 kilometers under construction and 179 kilometers in the planning stages. Japan has one of the world's longest high-speed rail networks, second only to China. High-speed rail in France. France's high-speed rail system, known as TGV, Train à Grande Vitesse, was developed by Alstom and operated by the state-owned SNCF. The TGV network serves cities across France and connects with neighboring countries like Belgium, Germany, and Switzerland. Many other nations, including the Netherlands, South Korea, and Spain, have purchased TGV trains or licensed French technology. In 1971, the French government approved the construction of the TGV Sud-Est line from Paris to Lyon, spanning 417 kilometers, with 389 kilometers dedicated to high-speed rail. Construction began in 1976, and the entire line was completed by 1983. This project was guided by three principles: building new high-speed tracks for passengers, ensuring compatibility with existing rail networks, and running more trains with fewer stops. The maximum speed of TGV trains reached 270 km per hour, reducing travel time between Paris and Lyon from nearly 4 hours to 2. The success of the TGV Sud-Est demonstrated the competitiveness of high-speed rail and led to further expansion of the network across France. More high-speed lines, such as TGV Atlantique, TGV Nord, and TGV Méditerranée, were built, with some trains reaching speeds of 300 km per hour. By 1991, the TGV Sud-Est had paid off its construction debt, and in 2007, the latest TGV model achieved a record speed of 574.8 km per hour. France now boasts one of Europe's largest high-speed rail networks, with over 3,287 kilometers in operation. This success has inspired neighboring countries, like Belgium, Italy, and Spain, to develop their own high-speed rail systems. France's TGV also connects with international networks, including Eurostar, linking France with the UK. High-speed rail in Germany. Germany has a long history of rail transport, beginning with its first railway line between Nuremberg and Fürth in 1835. Germany's high-speed trains, known as ICE, Intercity Express, are considered the flagship service of Deutsche Bahn and operate across the country. Germany began its high-speed rail development in 1971, starting with the Hanover-Würzburg line and soon followed by the Mannheim-Stuttgart line. Both lines opened in 1991, with the Berlin-Hanover and Cologne-Frankfurt lines following in 1998. Unlike Japan and France, Germany's high-speed rail is designed to accommodate both passenger and freight trains. Alongside new high-speed lines, Germany upgraded existing tracks to allow speeds up to 200 km per hour. Today, Germany's high-speed rail network covers over 3,264 kilometers, with both domestic and cross-border lines connecting cities across Europe, including Amsterdam, Copenhagen, Zurich, Brussels, and Paris. Countries planning to build high-speed railways. Russia. In the late 1980s, the Soviet Union began planning for high-speed rail development. They aimed to create eco-friendly transportation along key routes between Moscow and other cities. One priority was building a high-speed line between Moscow and St. Petersburg. In 1991, the Russian High-Speed Railway Corporation, PZD, was established to manage the design, construction, and operation of these railways, along with the development of high-speed trains. The Moscow St. Petersburg line is 654 kilometers long and serves a population of around 30 million people. The trains on this line are designed to run at speeds up to 350 kilometers per hour. Russia also developed a new type of high-speed train, the Condor, which has a top speed of 250 km per hour. The country's long-term plan is to connect major routes like Moscow St. Petersburg, Helsinki and other European cities, including Warsaw, Berlin, and Paris. Currently, Russia has about 845 kilometers of high-speed railway. India. India has also set long-term plans for high-speed railways. The aim is to build rail lines connecting major cities like New Delhi, Mumbai, Calcutta, and Chennai. They've started with feasibility studies for routes such as New Delhi to Agra and Mumbai to Ahmedabad. High-speed rail has become a global trend, with many countries investing in it due to its social and economic benefits. High-speed railways have proven to inject new life into the railway industry, providing fast, efficient travel solutions. High-speed railway development in China. The need for high-speed railways in China. China is a vast country with a large population, and it requires a strong transport system to connect its regions. Railways are the backbone of China's transportation infrastructure. With their ability to move large numbers of passengers and goods efficiently, railways play a crucial role in the country's economy. High-speed railways offer numerous advantages in terms of speed, safety, and environmental impact, making them the best choice for China's future transportation needs. Building high-speed railways is a key part of China's strategy for the 21st century. It will help the country meet growing transportation demands and promote economic and social development. Developing high-speed railways to increase transport capacity. As China's economy grows, so does the need for faster and more reliable transportation. Currently, China's railway system struggles to keep up with the demand, especially during peak travel times like the Spring Festival and National Day holidays. High-speed rail can help alleviate these issues, offering faster and higher capacity services. Key routes, such as Beijing-Shanghai and Beijing-Guangzhou, are vital for connecting the country's major economic zones. Developing these high-speed lines will improve the efficiency of the railway network. Meeting residents' travel needs and economic growth. In recent years, Chinese travelers' expectations have shifted from basic travel to more comfortable and faster journeys. High-speed railways can meet these demands, offering safe, reliable, and efficient services. They also help improve travel between regions and cities, making travel more convenient and boosting economic growth. China has over 245 cities with populations exceeding 500,000. A significant portion of long-distance travel needs to be served by rail, and high-speed rail is crucial to meet this demand and support social development. Promoting regional economic development. China's eastern regions are densely populated and economically developed, while the western regions are less developed but rich in resources. High-speed rail can help balance this development by improving transportation between these regions. By connecting East and West, high-speed rail can promote regional economic growth and better resource distribution. Supporting China's urbanization strategy. China's urbanization is accelerating, with predictions of 72.9% of the population living in cities by 2050. High-speed rail can support this growth by providing fast, efficient transportation between major cities. This will encourage the expansion of urban areas and improve overall city development. Enhancing railway equipment and industrial manufacturing. High-speed rail involves advanced technology across many industries, from electronics to environmental protection. Building these railways requires importing, developing, and integrating technologies from around the world. This not only boosts China's railway system but also helps advance other industries, closing the gap between China and developed countries. Building a comprehensive transportation system. High-speed rail can significantly improve China's overall transportation system. It will ease the pressure on current rail lines, enhance efficiency, and reduce costs. As high-speed rail grows, it will help create a balanced and efficient transport system across the country. In the next decade, China plans to continue developing high-speed railways, aiming to match the technological advancements of developed nations. The future of high-speed rail in China looks bright, and it will play a key role in the country's continued economic growth. The concept of building high-speed railways in China was first introduced in the mid-1980s. Over a decade, the government assembled experts and scholars to conduct comprehensive evaluations. After detailed studies, they concluded that constructing high-speed railways was both technically feasible and economically viable, providing significant social benefits. By the early 1990s, consensus was reached that it should be built, and it should be built as soon as possible. Quote, from December 1990, when the Ministry of Railways completed the report on Beijing-Shanghai high-speed railway line plan, to January 2008, when the construction of the Beijing-Shanghai high-speed railway was approved, several key governmental bodies collaborated in demonstrating the economic and technical viability of the project. On December 22, 1994, the Guangzhou-Shenzhen Railway was reconstructed, launching China's first express passenger train at 160 km per hour. This line became China's first quasi-high-speed railway, marking the nation's entry into the era of high-speed trains. The Guangzhou-Shenzhen line is often referred to as the testing ground for the development of China's high-speed railway network. In 1998, the construction of high-speed railways was included in the 10th Five-Year Plan. By August 16, 1999, China began the construction of its first dedicated passenger line from Qinhuangdao to Shenyang, completed in 2003. This was a significant step in China's high-speed railway journey, helping to accumulate experience in technical standards, construction, and operations management. In 2004, China unveiled its first medium and long-term railway network plan, setting an ambitious goal of 12,000 kilometers of dedicated passenger lines forming the 4 vertical and 4 horizontal high-speed network. On July 5, 2005, construction of the Beijing-Tianjin intercity railway commenced. By August 1, 2008, this railway, China's first independently developed high-speed line, was operational, with trains running at speeds of 350 km per hour. This reduced travel time between Beijing and Tianjin from 2 hours to 30 minutes, solidifying China's global standing in high-speed railway technology. On December 26, 2009, the Wuhan-Guangzhou section of the Beijing-Hong Kong high-speed railway was opened. With a speed of 350 km per hour, it set numerous world records, such as the highest speed in a tunnel and utilizing double pantographs. This project marked China's ability to build long-distance high-speed railways, exceeding 1,000 kilometers in length. On February 6, 2010, the Zhengzhou-Xi'an high-speed railway began operations. It was notable for connecting central and western China at a speed of 350 km per hour, as well as being the first high-speed railway constructed on collapsible loess, a significant engineering achievement. On July 1, 2010, the Shanghai-Ningbo intercity high-speed railway opened, marking China's ability to build high-speed railways on soft soil. This line strengthened the economic integration of the Yangtze River Delta region. In late 2010, China completed construction of the 1,318 km long Beijing-Shanghai high-speed railway, which became operational on June 30, 2011. During testing, CRH-380A trains reached a speed of 486.1 km per hour, setting a new world record. By December 1, 2012, the Harbin-Dalian high-speed railway, the first in an alpine region, was completed. This line connected major cities in northeast China, operating efficiently even in harsh winter conditions at speeds of up to 200 km per hour.